Hi, this is TJ from smokescreendesign.com, and today going to debunk Smug Will's Easy Guitar. So he did this video. Well, he did this video about flat earthers are full of shit. Flat earthers are retarded. If you've seen it, you heard it. If not, I guess you could listen to it if you really want to. So that video that I did, I basically just asked a question because I wanted to see what other people thought about his curve. Let's see here. Got a video. We'll just play that real quick and we'll see. This is just of his curve.
Everything is perfectly level right now, and all I'm going to do is I'm just going to turn this. Now, the curve is there, okay? It's hard to see on camera because you can't see the full view like I see, okay? But if we were even higher up, at a higher vantage point, the curve is more apparent, okay? Unfortunately, there's nothing around here except this roof of an apartment complex over there. I don't think they're going to let me on.
Alright, so he debunked it that there's no such curve. Or so he says, but I think it's time to free Willie. Need to free his mind. We're going to come back to that. So when I made this video, I was just, as I mentioned, I was asking people what they thought. Some people got upset because I was so ambiguous and I didn't tell you what. Look, I was just asking a question, and I'm glad I did because we got a lot of good answers and some things that I didn't even think about. But when I first watched that curve, I already had in my mind what was wrong. I could spot it. So I just wanted to go through some of the comments I thought that were good. People like Willseasyguitar and other globe believers say, "Oh, flat earthers can't agree on anything." Well, yeah, that goes with the globers as well. They can't agree. He says you can see curve just by standing at the beach. But then we have people here like this person, no one's flower. Will simply hasn't done his homework, nor does he admit seeing what is before his own eyes. Even a giant sphere, the edges of your circular section, which constitutes your horizon and which you view as from the center, appears as a flat line around you. Okay, maybe it wasn't that one. But we'll see the different perspectives that people were bringing. And this person, as if you can see further out to sea than the fixed points on each side, thus giving the appearance of a slight curve. So that's definitely a possibility. John ThinkPad said there's no curve at much higher altitudes, high above the clouds. So this one could be a measuring glitch or a water surface line optical illusion like Fata Morgana. So I haven't heard of that. It's something I could look into. International Cheese Eater says, I think he's kidding himself. There may be a swell, but the Earth's curve would be imperceptible at that height. However, one of the main reasons I'm still a globie is the South Celestial Pole. If anyone can explain how that would work on the flat Earth, I'd be interested in to hear. So, I mean, we've got people who believe in the globe and are saying you can't see a curve by standing on the beach. Rob Durham brings out a good point that if he was able to pan a full 360 degrees, would the alleged curve continue? How would the curve meet up with the starting point after a full 360 degrees if it's a constant curve? Then Mr. Fish1777 asks, was he turning the camera by hand? Did he level it first and then put the camera on? Well, in the video he says it's perfectly level and we're going to investigate that. So here he responded, I leveled it. I've done a lot of camera work with tripods, really cheap tripods and tripods that cost hundreds of dollars. So I know a little bit about working with the camera on a tripod. Eyes Wide Open said, it's tight. Even if you were on a ball with a 25,000 mile circumference, you could not see a curve. It will appear to be flat due to perspective to the vanishing point. It's just stupid to even look for a curve standing on the beach, but it's what to expect from someone looking for a curve on a flat plane. And then J-Max says, eyes wide open is precisely correct. Whether you're on a globe or a flat earth, you will never see the sides drop off or the middle be higher. Imagine an ant, which this is a terrible analogy, an ant standing on a basketball is still really too tall. It would have to be a much larger ball. But imagine an ant standing on a basketball. If the ant spins around in a circle, you'll always see a flat horizon. Same goes for an ant on a tabletop. This horizon test provides an impossible result. Could be due to the fact that your camera was not perfectly level. Were you using a level? Regardless of the cause of the error, the results are null, not possible on either a globe or a plane. Now, something I want to point out here, when leveling a camera, there's usually, if you're using a tripod, there can be a level on the base of the tripod, and then on the swivel, on the more expensive ones, you could have a second level. Now, you can level both of those, and I've had so many issues with it where I've leveled them and the damn thing was still not level, so I actually bought a level, and I leveled the all of the legs individually and leveled the camera to make sure it was absolutely level, because, well, we'll look more into that. Not too long ago I came across Good of All 72, and he's been doing some experiments. And what he did in this experiment was took a wire and went from one pole to this other pole. And there's two locations. There's this location here on the left, and there's a location on the right, and it's 30, it says 30 miles, but I think he rechecked and it turned out to be 31 miles. So we're looking at 30 to 31 miles across. Now, just to throw in here, I watched some Alaskan shows on TV and homesteaders, and this one guy was putting up a wire across a tree, and he said the homesteader's level is the ocean. They used the horizon in the ocean to level a wire, and I found that pretty fascinating, especially because he's not involved in this flat earth debate, may not even know that it exists. So let me go and play this video so you can see some of this. Now what you'll notice is that even though he has this wire, he's got a tripod, his camera is not level, but he has a base to measure against with his horizon. Remember, from side to side is 30 miles.
See how when I pivot the camera, I'm in sand right now. The tripod's in sand. I can't get it
So there's this really thin wire. It's hard to see.
Perfectly level. When I center the shot, I can get the camera pretty level to the wire right here. In the background you have, this is not my zoom lens, this is my other lens, but you can see Toronto. And then over here, that would be the point of land. There is St. Catharines, Niagara area, and then you're getting into New York over there, which you can't see, but we know Toronto is 30 miles from here, and from Toronto to Niagara is 30 miles. So
now with this, looks like we got some refraction going on, starting to happen there, but it's commonly said that you can't just be at ground level, look at the horizon and see a curve, which is what Willseasyguitar says you can, and well, if you can, then your video is debunked right now, because going this distance of 30 miles and there's no curve at all. We'll see. We'll take a look at your curve and see how deep it goes, how far it drops. So it's, on one hand, I can agree that with this you won't be able to see a curve in the horizon, because how far out is this water line? Is this water line 3-4 miles out? Because it may not, this water line may not go all the way out to that city. So because of the convergent lines, that the water will rise up to meet your eye level, then that means the actual horizon that these two cities would be on would be hidden. And just like with appears that we can barely see these other cities that we're not seeing down to the base, so this would not be the horizon that we could measure. And
What's up?
let me go, we'll come back to that later. All right. So I started doing some looking around, and I asked him, I said, well, where were you standing when you took the shot? Because I wanted to check the distance. So he said he was in Del Mar, California. It was about 30 feet up or so, maybe more. It was Del Mar Beach. So then I went digging around, and I found the Del Mar Beach, and then I found on the far left was La Jolla, and or Yoya, however you say it. And then on the right was Encinitas, Seacliff Park. That seemed to be the right spots for comparing with his video and comparing with what I could find on Google Earth and Google Maps and images. So he says, sounds about right that La Jolla is on the left and Solana Beach is on the right. So he was between these two, and this is La Jolla Shores down here at the bottom. So from down there up to this would be the edge of Solana Beach. This would be the edge here that would curve out, that we would see. So if that's true, that's the 2 points we're looking at in his video, and we're going to take more look at that, then we're only looking at less than 10.5 miles. But if it's up to Encinitas, then we're looking at just under 13 miles. So between the two, 13 miles and 10 miles, we're looking at pretty small distances, but it would have been interesting to get down here and see if you could have seen all the way over there. Alright, now what I did was I went the halfway mark. Since we have the hump in the middle, and to the right of that and to the left of that it drops. So what I wanted to find out was, what is the drop from the middle to the left instead of going the full distance, because we're not looking from one end to the other. We're really looking from the center of the hump over to the left and to the right. So I just rounded up that 12.96 is 13 miles. So we are looking at, which would give him a higher drop in curve. So 6.5 miles, we're looking at a 28-foot drop in curve. But if it was 10.36, I went up to 10.5, again giving him more drop in curve. At 10.5 miles, then put that in half would be 5.25. So we're looking at 18, just under 18.5 drops. So is this what we see in his video? Do we see a 18 to 28 foot drop? 18 foot to 28 foot drop. So I've just got one. I put two, but I have just one drop because I've got one with the lines and one without the lines added. Curve. Yep, that's the one I want. All right. I did my best to try to match up the pictures I took screenshots of, and I had this in the first video, and now this time I added my own line here. So this is La Jolla, or is it La Jolla? Anyway, so this is that island there. Well, it's not really an island, it just comes out. And then he scrolls over, and this is where the water rises, and we see his line here. And then over on the right, this land here could be Solana Beach. It's possible that it could also be, as I already mentioned, Encinitas. So what we see here is that with the center, I just drew a line straight out. So the drop and curve is going to be at the top of this land. That's how much the curve dropped. And on the far left side, the drop and curve was way up where there's some sort of hotel that sits up on top. I'm going to show you, but there's another one that sits really low. And I'm going to show you why I think that it's the higher one. So now I've got a marker for a distance and curve that it has dropped. And that's why we're going from left to right, because the drop is from this bulge over to the right and the bulge to the left. So on Google Earth, we have, this is the La Jolla, and we've got this hotel here, and this is further down on this land. We've got this one over here that's higher up. And why I picked these two out, because these are two cubes. Let me go ahead and get that other image. So just now realizing that I kind of blocked that out, but I want you to see. So you see that there's this box that's on top of there. So it was pretty difficult to determine if we're looking at this one or if we're looking at this one. So the base of this hotel using Google Earth says it's 44 foot in elevation. So if that drop in curve is at the base of this, which it appeared to be higher, but if it's at the base, we're looking at 40-foot drop in curve. If it's anywhere above this, then it's 212 foot in drop in curve. So we've got a big drop here. Now here's this other one that's also on this land. The base of this one is 175 foot drop in curve. So you can see that this one is much higher than the other one. It's almost as high as the roof. That's the base. But the roof of this is 321 foot, 321 feet in elevation. Now if we look at the other side, let me do this. So we have this first one is way out here on, which appears more towards the edge of where the ocean meets the land. We have this one that's further on the land. Remember, he would be looking over from this direction somewhere out this way. And we see this one is closer to, we've got the increase in elevation that goes up. So let's take a look at that again. So this is why I think that this hotel here is the other one we are looking at. Because you can see the height of this is almost, not quite, but it's kind of high up there. This other one I'm assuming would have to be somewhere in here, but I'm not sure. That's why I'm just going with, I think it could be the higher one, but maybe it's not. Maybe it's really the smaller one. But let's go to the other side. So Solana Beach, if that was this one, we're looking at 63 feet in elevation. But if it's Encinitas, then we're looking at 100 foot in elevation up here. So again, do we see 18 to 28 foot drop? Well, based on this, we are seeing a bare minimum. It's more like 60 foot, but bare minimum we are most likely seeing, we could be seeing over 175 foot in elevation, but this might not be the right one. So what we might be seeing is somewhere between 44 feet and 212. So I was saying maybe like 44 to 70, 60 feet in elevation. Now this one does sit far back, so even though it's higher, it's possible that you may not be able to see this. It might be hidden. So that's why I just go with either one. So we're looking at 45, 60, 70 foot in elevation, or drop and curve. So we definitely are not seeing that 18 to 24. We're seeing double. So that means that the Earth curves dramatically more where he would be. Not very likely. Now, this is what I picked up right away as soon as I saw the video. Let me get back to here. So here's my red line. We'll get to that in just a second. And notice that this kind of the cliff drop off, and that's one reason why I was thinking that possibly this might be that one further distance, because that other one I would think would have to be closer out this way. But anyway, on this side, since it goes up, we are looking at easily 100 foot drop and curve. Real easy. So this could be 100 foot, and then this could be that hotel lower elevation, and it could be up 100 foot. Easy 100 foot. Now, like I said, I did the best I could with doing a screenshot. So I even used I had a line on the video just to see, and when I did the line on the video, I mean, it was up at the same spot, so I decided to do the screenshot. Now we're going to get to the boat. When he was recording, there was a boat that came into the screen out on the water. And one of the things I noticed was that as you go along, the boat, remember, let's see, should be between the red line to two red lines. But as you move, the boat starts going up. Now the boat's completely out of the red lines. Completely out. Completely out. And again, I did the best I could. I just took screenshots. I lined up the horizon. Now if you look from here to here, how drastic that changes in the water curve. Like, this is a really short distance, but it jumped up pretty high. I'm going to show you why. I mean, look, even here, it's not that far of a distance of a turn, but the water jumped up. And you see the boat's completely out of the lines. Like I said, did the best I could. I matched up the horizon, and for the most part, I mean, we've got the slight curve or the slight increase, but then a jump. I mean, this is a sure sign of a unleveled tripod and even a jerky tripod. And I'll show you that one. So we got the boat, and now we're going to look at this object, which you see does show up with the boat. And I was looking at these strands of grass or whatever these are that are out by the water, and I could see just by watching the video, I saw how they dropped. But the problem is that they're also waving in the wind, so it's really hard to do something like this with those. But I did notice that. And even in the beginning with the people, if you did the same thing with them, you'd notice a slight change in their elevation with the turn. Alright, so here this object as he turns comes into the screen. I took screenshots, lined up the horizon, and we see that the back corner is touching this, and I've got this right below this box. But another thing I noticed was that it's just this thing changes. These lines are perfectly straight, and you notice the water doesn't line up because I didn't perfectly match up the water. Like I said, I matched up the horizon, and we see, and you can see it in the video. I mean, you just put a line across the video and you'll see that this thing drops. This is not level. Camera is not level. And you even have people out here in the water that you could use as a base. Unfortunately, the quality of this video is not that great. There's nothing else to really base this on. We don't have anything to see what is going on with the video while he's recording it. Now he has this line here, but we needed something like these objects that are part of the scenery to be able to see any kind of shifts in the level of the camera, any kind of jerk motion up and down, which I did see some, and I'll show you. Let's see, boat curve. Okay, so that's it for that. Let's go back to the video. And let me put this, let me slow this down. I'm going to turn off his audio. So here's this person, which they're running, so it's hard to stay with them. And let's see here. So with this being off level, that would make this side to start to dip down, which makes the curve look like it is, makes it look like it's curving. There's the boat. Now, right here he says, watch the water level lower. All right, so let's go back a little bit. If you pay attention to this red line and this boat and the horizon, you'll see how it just there's a jerk in the camera. When he moves, the camera like dips down, and you'll see there's a quick jerk. See now the camera, see how much of that has dipped down? And now when he zips to the right, what happens is this line, it moves back up. Whoops, I went back too far. So as he's moving, and when he stops, as he slows down, this horizon begins to move up. And as he jerks, now the horizon sinks back down because I think the level of the camera is off, and as he moves it, the camera is either moving up or down. So when he moves it, this red line moves up, which gives the appearance of it dropping. So this is actually lowering down, not the horizon, but the camera is. And if you watch it, you play with it, if you can put paper on here, and you can see exactly what I'm showing you is that it's funny that you put debunked here because I just debunked your video. But you put paper there if you don't on the screen, if you don't have the ability to put a line across to sit there and watch it. But you'll see that it's not level. It's just, it's messed up. So this was a comment I didn't show yet, and this was one of my initial thoughts before I saw this comment. And it says there are several possible reasons for the curved effect. One reason would be an ocean swell or tide moving in. Another reason would be a very slight upward tilt of the camera perpendicular to the shoreline. This would give the slight upward curve tapering off to each side. Another reason would be a slightly bowed base plate the camera swivels on. This test was not performed with precision scientific apparatus. I used to work pour concrete and have used survey transits many times. These instruments are supposed to be exact, precise, but with wear and tear on the base plate and bearings, they can easily give false readings. Or if in setting up the instrument, you do not constantly check and recheck in all directions, continue to check and recheck and all. So basically, there's just something wrong. The camera is not level at all times when it's moved. The camera moves up and down, gives a false impression of a rising and sinking horizon. And as I already showed you, that objects that pass by are not staying level. And I showed you that the drop and curve easily 100-foot drop and curve, minimal 45 feet. So it doesn't go with the calculations what we should see. So I said your camera definitely isn't level as I suspected. Others have commented that the tripod can have issues which can create the illusion of a curve by the way it can move up and down. This is exactly what I think is happening. This also explains why the drop in curve is 60 or more feet, which is way too much for 6.5 miles. I'll show you soon how I came to this conclusion. And it says you can see the curve without the camera. I know everyone is trying to find flaw with my video, but if you were there in person, you would see the identical curve. You just need to accept it. Well, sorry, but us retards, we don't know how to do experiments, and we don't know how to debunk videos, so I'm not sure exactly if I was able to debunk your curve. And no, I'm not going to just accept it because, as I told Will, if I need to just accept it that there's curve, then you need to just accept it that it's flat. So if we're going to go on that logic, then that's what we need to do. And we know science at times tells us you just need to accept it, or they make fun of people, or they say science is true and whatever I say is science, so it's fact. We know NASA says you just need to accept it. We know government says the same thing, but no, we don't. And too many times, religion leaders say you just need to accept it. But what do we find? That so many times what we're told we just need to accept, that it's just not true. So I already showed you that you can set up a base to compare against, like that wire. In this case, may not have the ability to do a wire, but there's got to be a way to compare what really is going on. And it's your curve is not proved. So that's it for this video, and it's completely debunked that you proved curve. Unfortunately, you wasted your time. I would like to not only see you go from side to side like that, but I'd like to see you do more experience along the along that ocean. Go closer to each part of the land, and then go from there, go straight out from the land and go from there to the left. So my assumption is that what you did, let's see. My assumption is what you did was you went to the center, so you went to a center point, you leveled it based on probably a level in the tripod. My assumption is your tripod probably isn't that good of a tripod, a little cheapy one, which I've got a couple cheapy ones. I level that damn thing off, and then I spin it, and it fucking curves up and down and just gets on my nerves. So my assumption is that you pointed out straight out, and then you leveled it, so then when you turn it to the side, since it's not level going to the right, it curves down. Since it's not level to the left, it curves down. Besides that little jerky motion I saw, where as soon as you grab the tripod and you forcefully move it, and it moves pretty fast, and then the horizon jumps up. So that's why it appears to watch the water level lower. So that's why it appears to lower, and it's got to be smooth, slow motion, so that way you're not jerking it to where this red line drops down. Oh, so that's all I've got.